Okay, so I did my PhD at Universidad Autónoma de Madrid in the topic of theory of plasmonics and metamaterials, and in the end of my PhD I moved towards quantum plasmonics and quantum light matter interactions. After that, in 2014, I moved to Imperial College London as a postdoc and a Marie Curie Fellow, where I went back to more classical studies of plasmonics and metamaterials. And I also started to develop an interest in other areas, such as topological photonics. And at the end of this period, I started research on time-varying media. Then, after that, in 2019, I moved to Lisbon, where I started to set up my own research lines on these topics. Very recently, I moved back to Universidad Autónoma, IFIMAC, where I am establishing my group in the topic of time-varying nanophotonics. So the topic of the ERC Starting Grant that I will be developing here at IFIMAC is the study of quantum electrodynamical effects in time-varying nanophotonic media. This research is motivated by recent experimental results in the field where it has been shown that it is possible to modulate the optical properties of nanophotonic media in time at very fast timescales and also very strongly. So in this context, the study of the quantum effects associated to light matter interactions in these setups is very promising. The main goal of this project is to develop the theory that is needed to study these processes. This is challenging because one needs to perform a quantization of the electromagnetic fields in an environment that is very far from the more typical one that is very well known, that is quantization in free space or in vacuum. In contrast to this scenario, here we have nanophotonic media that are nanostructured in the nanoscale, that are characterized by frequency dispersive material properties that also encompass loss, and performing the quantization of the fields in this scenario is not an easy task. The goal of the project is to apply this framework to study different quantum electrodynamical processes in these setups. On one hand, I plan to study light matter interactions, both for the case of interactions between the electromagnetic field and quantum emitters, or between several quantum emitters, and also with free electrons traveling in this media. On the other hand, I will also study quantum vacuum processes, such as the generation of photon pairs from the vacuum fluctuations, or thermal and non-equilibrium forces. So this project aims at developing fundamental research, but there are also promising outcomes. One important aspect is that time-varying media allow to overcome two fundamental limitations that usually constrain conventional nanophotonics. These are the principle of energy conservation and reciprocity. So, for instance, breaking reciprocity allows for one-way unidirectional photonic interactions, which is something that is a key resource for information processing, both at the classical and quantum level. And this is usually very challenging to achieve in photonics, especially at optical frequencies and in the nanoscale. And the time-varying media would offer a route to do this. So it is very promising that the experiments that are now being carried out at high frequencies and in the nanoscale already hint at these possibilities. And the Starting Grant TIMELIGHT is framed in this context. It is a platform that is very promising for the development of quantum technologies at room temperature, optical frequencies, and in the nanoscale. So the goal of TIMELIGHT is to join these two worlds of nanophotonics and time-varying media to develop new forms of QED light matter interactions for new applications. So this ERC Starting Grant project will give me the opportunity to establish my research group by hiring a number of PhD students and postdocs working in this topic, but also it will give me the possibility to establish new collaborations and also strengthen my network, both in theoretical research but with a focus on experimental groups. And with this, I will look for expanding my research into the area of quantum nanophotonics, and in the process train and motivate young researchers so that they enjoy exploration of fundamental science.